In this final film about data networks, we have network components, and I will cover both hardware and software that you will find in a network. And software meaning servers that are in a network. So here are an overview of the different devices I will talk about. Hub, switch, bridge, repeater, router, and gateway. Let's start with the repeater. The repeater is simply a device that refreshes the signal. So it takes, when the signal becomes weaker, it analyzes if it's a 1 or a 0, a high or a low, and as long as it's able to distinguish a 0 from a 1, a high from a low, it can rebuild the digital symbol and retransmit it nice and refreshed. So it has only got to do with layer 1 properties in the OSI model, because it's only used to safely send a bit from one computer to the other, or from one segment of the network to the other. So it's only concerned with simple bits, not the meaning of the set of bits. A bridge, on the other hand, is like a repeater. If you see the figure here, it sits in between one group of computers and another group of computers and makes a bridge between the two network segments here. However, it doesn't only refresh the signal, it also looks at the local addressing and analyzes if the message is, if it's necessary to send it across the bridge, or if it should be kept on one side only. So for example, if A wants to send to B here, then the bridge will not transfer it to the other side, and therefore lessen the traffic on this side here. While if A wants to send to C, it will have to bridge it over to segment number 2. In that way, the amount of traffic in a network is reduced, and which a repeater will not reduce the amount of traffic. So therefore the bridge will have to analyze the address, the local addressing, in order to know if it's supposed to send a message across the bridge or not. Therefore it's layer 1 and 2. Layer 1 for physical, because it has the ports and the connectors, so it has to know about the physics of the network, but it also has to know about the local addressing, hence layer 2. Number 3 is a hub, and in English a hub is the center of a bicycle wheel here, and you will also find a hub, for example, in packet transmission with the postal system, where you can, for example, say that you have a European hub in Amsterdam, for example. A hub is a central device in a star topology network. So you connect all your computers to the device here, and the hub makes sure that a message that comes into the hub is sent to all the other devices here. So therefore the hub doesn't have to be concerned about addresses, because it will simply forward the message that comes from the green node here to all the other devices here. Nowadays hubs are rarely used at all, because what we have instead is the switch. A switch is a device which also is a centerpiece of star topology, but it's able to make connections based on the local addressing. So it takes, if this device wants to send to this one, it will make a connection for these two only. And it can simultaneously make a connection for these two devices here. So it will have to read the address and send it forward. So hub does not read addresses. Still, it has ports, connectors, so it has to know what a bit looks like in order to retransmit the set of bits to the other ports. A switch will also have to know the local addressing. Hence, it's layer 1 and 2 in the OSI model. You also have more advanced switches, layer 3, 4, and 7 switches, which analyze even more. So level 3, for example, they also analyze IP addresses, but that's not a part of the syllabus for this course. So it's for information purposes only that you will sometimes hear, for example, a layer 7 switch. Then you should know that it's a kind of switch, but it's more advanced. So in general, if you talk about switch without adding what kind of layer it is, it's a layer 2 switch. That's the common switch. A router is a device that that knows to which network a message should be sent. So this is a device that listens to or reads the information from layer 3 in the OSI model, which is global addressing. So a router knows in which direction a message should go in order to reach its final destination. And routers can also talk to each other, which means that they send messages to each other and messages about which routes that are most effective at the moment and so on. If there is a part of the network that is busy, the router will tell the other routers that they should avoid that part of the network. So routers are found, of course, in local area networks like here at our campus. We have a number of routers, for example, between the different floors or the different parts of the building, and of course between K1 and K2, the K1 and K2 building. Also, you will find routers in public networks. So, for example, between Bergen and Oslo, you have a number of routers which will forward messages on the way from Bergen to Oslo, but they can also redirect messages, for example, up to Trondheim, or even abroad. Gateways, they are network devices that are able to translate between protocols. So if you have a network connection here that is not based on TCP, IP, and Ethernet like here, you have something that is, for example, an ADSL or a 5G cell phone message. The gateway acts as a protocol translator, so it's able to read from this protocol and send to another protocol set on this side here. So it's a protocol translator. It has impedance matching in order to connect to the different kinds of network. Bitrate conversion, for example, this traffic here could be much faster than a download speed from the internet, but this gateway here will, for example, when a message comes from here, it comes really fast. The gateway can buffer it and send it onto the internet at a suitable speed. So it has bitrate conversion in order to match the speed of the network that it's supposed to be sent onto. Error isolation, if you have a crazy computer here which sends data in all directions, this one is able to stop that in order to not make traffic conduction onto the internet. And signal transformation, which is protocol translation actually.